Q&A sessions. And also, for a non-technical reason, some of the slides may show up zoomed in. So if you think that is the case, please use the zoom function by clicking on the magnifying glasses on the upper left corner of the slides. And this will be helpful for your vision. Finally, I would like to remind you that this is a conference for and by emerging conservators, so please respect one another for their exceptional effort of making this event happen. Some of our speakers will be presenting to a large audience for the very first time today, so please keep that in mind. Thank you very much.
Thank you, Pauline, for this introduction. So once again, I welcome you all to this third session of ConNext 2023. And for those of you unaware of the ConNext initiative, here is a short introduction. ConNext is a joint effort of the wood, furniture, polychromy, and modern material conservation training programs of, and this is a long list, universities of Antwerp, Amsterdam, Hildesheim, Cologne, Potsdam, Lincoln, Westin, Tomar, Dubrovnik, INP in Paris, and Ensave-la-Cambre in Brussels. It's a long list. As you all know, education is paramount for our future, and it all starts by sharing your hard work, new insights, experience, and knowledge. This is where ConNext comes into play. It is our mission to provide students and emerging conservator restorers with a platform where you can share your knowledge and engage with international colleagues.
Before we start, I want to take this opportunity to point out the ConNext book of abstracts to you. This PDF can be read and downloaded by scanning the QR code on the shown slide. The book contains all abstracts of the papers and posters presented at the 4 sessions of ConNext 2023. We will post a direct link in the chat as well. And as Anna already mentioned, today's session is about surface phenomena, a topic that is, of course, fundamental in original techniques as well as conservation treatments. These questions have an impact on conservation studies and choices. We therefore invited a keynote speaker who had a fair share of experience with this topic. Please, let's welcome Dr. Emmanuel Mercier from the Royal Institute for Cultural Heritage in Brussels.
Emmanuelle Mercier is a conservator restorer and art historian. She studied at the University of Paris 1, Panthéon-Sorbonne, and completed her doctoral thesis in 2008 on the polychromy of 13th century Mosin wooden sculpture at University of Liège. Emmanuelle is responsible for the study and conservation of polychrome wooden sculptures at the Royal Institute for Cultural Heritage. She is a lecturer at the École supérieure nationale des arts visuels de la Cambre since 2012 and since 2016 at the École du Louvre. She is also a corresponding member of the Royal Academy of Archaeology of Belgium and a member of the Advisory Commission on Cultural Heritage for the Fédération Wallonie-Bruxelles. Emmanuelle, welcome. It's a pleasure to have you here and you can start, please.
Can you hear me and see me? Yes?
Yes. Yes.
Okay.
Perfect.
Thank you. Hello, everybody. Thank you, Anna, and thank you for inviting me. So with that title, When Superficial Really Matters, I would like to discuss the impact of the surface on our perception of a piece of art or an object, and emphasize that in terms of treatment option, nothing is ever black or white. And I will illustrate my talk with 3 case studies that I find quite challenging. So let's come to the first one, which raised the question when dark patinas interfere with the form. And so the piece that is presented is an altarpiece of St. George by Jan Bormans. It is signed and dated 1493. It's in the Royal Museum of Art and History in Brussels. You see it before treatment. And here is a detail. You see that it exhibits the bare wood with a patina, quite dark patina on it. When we started the project, we find a piece of parchment that was hidden behind the wooden block, and on which we have a date, 1835, and a signature, the name of Soest, which is quite well-known restorer in Belgium, active in the 19th century. And Soest has stripped a few altarpieces that it would cover with a reddish coating. So when we started the project, those patina, those dark coating, were quite questioning. So we had a lot of discussion inside the studio, also with a scientific committee. So different options were observed, discussed, maintaining the 19th century coatings. So does the dark appearance of the altarpiece correspond to a phase in its history or in the history of taste that should be preserved? Or on the contrary, is the removal of the patina an option? Is the dark appearance of the altarpiece disturbing our appreciation of it? In particular, the virtuosity of the carving and the fineness of the details. But returning to the original states raised the question, what is the original appearance of the altarpiece? Because it was always a discussion since the 19th century. Is it a non-polychrome altarpiece, or was it stripped in the 19th century? We think that it was never polychrome at that point, because we couldn't find any traces of stripping. Another question is a partial removal of the patina an option? Or, on the contrary, should the lightening of the patina be rejected because it creates a state that never existed in the in history, in the retable lifetime? We also ask the opinion of a few colleagues abroad in Germany, and their opinion was that 19th century patina should be restored as a historical material testimony. And also in France, where in the Musée du Louvre and the Musée de Cluny, a campaign of lightening of the patina was conducted quite recently after a very like a brainstorming. I mean, it was really interesting to discuss with the curator. So, but a restoration should not be mixing different periods based on aesthetic reasons. So we had to be very careful to understand the different coating that we had, we were faced to. So on both the original wood and also the pieces of wood that were added by Soest, we find a reddish coating that we really think it is by Soest, because we find it on other altarpiece. A second one that was applied not everywhere, but after the reassemble of the wooden block. Then a brownish protein coating that was not very homogeneous and, well, actually very dark. I mean, this we couldn't figure out for sure it was if it was Soest or if it was a later addition. Then we find a dark wax coating that for sure was couldn't be before the Second War, and a whitish wax coating. So let's have a look at one of the wooden block. You see that those coating are quite heterogeneous, but let's have a closer look. I think you can see that here there is a surface phenomena which can be described as an inversion of the value in the comprehension of the volume. So let's explain it. I think I can do that. Yes. See how on the upper part of the folds in the drapery, the patina underlines those parts, whereas in the hollowed part, the wood appear lighter. Here is another detail, and that phenomena create a false perception, of the volume. And it's quite interesting actually, because in the literature, some art historian had underlined the very graphic character of Jan Bormann's altarpiece or drapery, and one wonders if they were not influenced by that phenomena, and especially if they were working on photographs. So the final decision was to preserve Soest reddish coating, because he made actually a lot of addition and reflection. For example, on the whole altarpiece, 3 heads, 8 arms, 11 hands, 7 fingers, and pieces of garment, and a lot of things. You see here they are indicated in blue. But not only. Today, the altarpiece is really the result of Soest assembly, especially in the central case that you see here. All the reliefs that are indicated in red are supposedly not in the right location. That is to say, we couldn't find any original traces of assembly for those blocks. So this is really important to consider, and at the end it really seems that Soest restoration has a certain historical value to be preserved. So this is the altarpiece before, well, the main case before and after treatment. Or at IRPA we have a communication cell, and they say, oh, well, it seems you have done nothing for 2 years. Thank you very much. But I hope you see there is a difference anyway. And then what we have done is that we have removed the wax, the white one and the blackish one. And then if when it was needed, we lighten that brownish coating, even if we were not sure at 100% that it was soist or not, but sometimes it was really disturbing. So here is a detail where I think you see that phenomena is lightened, or I hope so. Okay. So I go to the second case study. They are shorter. So that with that question, when dirt is meaningful, it's a private chapel built in the 1470s in the Church of Our Lady in Bruges. And as you see, the ceiling exhibits the bare wood. It's oak, and but is also decorated with some patterns that are made of applied brocade on top of paper. So here is a detail where the pattern is well preserved with, you see the gilded finishing. But it's not the case everywhere. In other places, you see that the applied brocade is missing, and we have the paper that remains. Sometimes the paper is also very fragmentary, and sometimes it has almost disappeared. So we had only a few here, a few remains of the relief on the edge, but inside you only guess the pattern that was there because of the lighter color of the wood. So here is a detail during the cleaning test, and it was quite a challenge because that cleaning shouldn't compromise the perception of the lost decoration. It's like a ghost-shaped patterns in that case. I mean, nothing remain except the shape that is given by that difference in color. So here is the final result after cleaning on the most damaged part of the ceiling, of course, but you can still have that perception of the decoration. Okay, that's it. And the last case study, when a huge gap is meaningful. So that case study can announce the next presentation by Mafalda, because it's also raised the question of which face do we preserve or restore. And the puppet you see is from the Tone Royal Theatre in Brussels. The theatre is next to the Grand Place. It's a very active theatre with a lot of presentation. You have also, for those who are interested, an estaminet when you can have a beer. And it seems that you are like in a Bruegel painting when you are there. But that's not the point. And the puppet, so it's end of the 19th century, second half of the 19th century, beginning of the 20th is not very certain. and it's made of different material. I have to tell you also that the puppet is now getting retired. So it will be presented in a museum inside the theater. And so we were asked to restore it. But look at the face of that poor puppet. Is the worst one of all the puppets of the theater. So you see that I will take the. You see here a very big gap that shows an oldest or maybe the oldest faces. You have also a big eye made of glass. And then here on the edge of that lacuna, you see all the thickness created by all the layers that were applied before the last paint layer, the last face, which has small eyes. I mean, the eyes is getting deeper and deeper, smaller and smaller. So here on the left, you have detail of all those painted layers that were added to that face, because the puppets encounter quite a lot of damage produced by the battles on screen, on stage, sorry. So at the end, we have maybe like 30 faces. We didn't count since now, but yes, I count 60 layers, but you have also preparation layers in between. So before discussing with the theater the possibility, the option, and the practical also option that we have, we find it nice to have also the opinion of the public. And so during our last open doors that were in March, 2 days open doors, we share that case study with the visitors, and we had prepared a small inquiry to fill in, and where we ask, what does the face evoke to you? And should we keep the gap as a testimony of the puppet's life or for didactic purpose in the museum? Should we fill it and retouch it? Or should we uncover an old face? Or do you have any other suggestion? And the public was quite happy to participate, and also quite surprised. Some asked me, are you really gonna listen to our opinion? And I said, yes, for sure, because we don't have like a ready-made solution. So I will just finish with that question. What do you think has a young generation or the next generation? And your opinion really matters. So if you want to share it in the discussion, in the chat, or even you can also write to me. It's important, and thank you very much for your attention.
Thank you very much, Emmanuel, for this very interesting keynote. It's a source of reflection, I think, to guide our future conservation choices. And I'm sure there will be some questions from the audience. So please write them into the chat, and we will address them during our Q&A right after the next two presentations.
Sorry. Oops. I lost the script. Oh, sorry. Thank you very much, Emmanuel. As you mentioned, Mafalda will also address the theme, a theme similar to your last case study, which ways do we preserve? And Mafalda Afonso will be our first student contribution of this session. Mafalda has completed high school in visual arts and is currently finishing her third year in conservation and restoration at the Polytechnic Institute of Tomar. She already acquired experience in the conservation and restoration of a variety of objects and materials, such as stone, textile, graphic documents, sculpture, and furniture. So, Mafalda, please.
Okay. Are you listening?
Yes.
Okay, thank you. Hello, everyone. First, I want to thank you for the brief introduction and for the fantastic opportunity to participate in this event. I also want to say that all the work that I will be talking about today was developed during my degree classes at the Institute Polytech of Tomar. Thus, all the decisions taken were made in an academic context and under the supervision and advice of Professor Ana Vidal. Moving forward, I can pass the slides. Okay. Yes. Okay. But moving forward, what is the aim of this presentation, you ask? Well, many aspects related to the presented sculpture could be discussed here. However, time is finite. So I decided to focus on the overpaint that was completely covering the surface of the cultural objects. Overpaint that was distorting the visual perception we had of the piece. In this way, I will present the points that guided us during the complex decision-making process, which led to the removal of overpaints. In conclusion, I will speak of the discoveries that have been made. So, what will be covered? First, I will present to you a brief characterization of the sculpture, and I will show the careful observations that were carried out to better study this particular case. After, I will talk about the decisions taken and the important results that have been obtained. In the end, I will present the conclusion remarks and takeaways. On to the characterization of the sculpture. Since it has no specific attributes, it was only possible to identify the representation as a saint. And, due to its characteristics, it seemed to have been produced somewhere during the 17th or 18th centuries. When it first arrived to the laboratory, it came identified as Saint Joseph. However, with the progression of the investigations, this possibility was put away. It currently belongs to the space of a small Portuguese village chapel in which the environmental conditions have not proved to be the most suitable over time. Nevertheless, we are in belief that this religious edifice is not its original provenience. On the right of the slides, it is possible to see the poor condition of the polychrome wood sculpture when it arrives at conservation laboratory, as well as in these following photos. In terms of the technological study, it was possible to identify two blocks of wood that were carved to make the sculpture. On the right, one the right hand, and the other the rest of the body. In addition, a hole in the base was observed, which eventually resulted from the use of a lathe. On the right, you can see two accessory elements, namely a metallic radiance and a staff. It is important to mention that we believe that the last one mentioned is not an original attribute. To complement this study, we carried out careful and attentive observations of the sculpture of the surface layers. In particular, we invested in the study of the visual evidence presence of overpaints. Therefore, to complement the macroscopic visual observation, we proceeded to the observation of cross-sections by optical microscopy and opened the necessary survey areas to better understand condition of several layers observed. It all started with the indispensable macroscopic visual observation. During this phase, there were clear evidence of underlying polychromy that was perceived to be of higher quality than the more recent ones. In addition, the most recent layers were in very poor conservation condition, and already with significant material losses, factors that influence the decision-making process. We had to face two different situations, one concerning the overpaint on the vestments, and the other concerning the overpaint on the flashstones. For that, we resorted to the observation of cross-sections by optical microscopy for both cases. In this slide, I present the results referring to the vestments. Interpreting the microscopy photography, it was possible to identify a total of 10 layers, between paint layers, preparator layers, and even varnish ordered layers. Thus, we are able to perceive that over a primitive stratigraphy related to what is called Stofado technique, there had been two subsequent moments of overpainting. In addition, using a digital microscope, we made our investigation even more solid. What you're seeing is a detailed photo, an ampliation of the Stofado technique surface. Onto the flashstones, there were some variants. We identified 10 layers, of which 4 corresponded to layers of paint. Thus, over an older polychromy, not 2, but 3 moments of overpainting had occurred. In these photos, taken also with Dynolite, I present the 4 different paint layers that were observed, since it was an examination method also used and quite informative. After the in-depth study carried out, we move on to the decision-making process of the treatments to be carried out. And with all the data collected, we decided that it would be worth proceeding to the removal of overpaint to recover the uniform aesthetic appearance of the sculpture and to highlight its technical quality. The intervention methodology displayed on the screen was planned, and thinking in the context of this communication, it is important to highlight the process of overpainting removal that has been taking place and which is not yet being concluded. The vestments area was treated first, for which was used a removal method based on the use of a polar solvent gel, whose components are listed on the screen. Whenever the time of action ended, it was carefully removed with a cotton swab dipped in isopropanol. In this area, we have to remove all the layers until we had reached the ones related to the rich Stofado technique. On the other hand, in the flashstone areas, we decided that the oldest observed overpaint would be the one that would be left visible, since we realized that there was a significant risk of that the oldest polychromy would have too many material losses, which would negatively affect its subsequent reading and contemplating. Thus, a compromise solution was chosen, with the objective of avoiding an heterogeneous aesthetic experience of the sculpture. For this step, we opted for careful and successive mechanical removement of different layers, which made it possible to strictly control the process. With the evolution of treatments, it was already possible to make important discoveries that enrich and improve the understanding of the sculpture and its history. In this way, it was possible to corroborate the initial observations that were carried out. Simultaneously, the careful study of the multiple layers made it possible to perceive the oldest ones presented a higher quality, something that did not leave us in indifference. It was also possible to better define the period of production of the sculpture, which is associated with the Baroque era, since the decorative technique known as tofado was widely used in Portugal and in Spain during this period. Besides that, if you remember, at the beginning I mentioned that the iconography of the sculpture representing a saint is not defined. However, after the removal of overpaint and with the study of its decorative primitive work, it was possible to make an approximation to Saint Francis Xavier. To complement the investigations, I also did the graphic representation of the patterns discovered in the vestments decoration, which were a total of 5. In the image, the colors assigned to the 5 different patterns correspond to the arrangement in the sculpture. To conclude, I will say that I'm very grateful to have had the opportunity to work a sculpture that challenged our critical thinking and made me grow both academically and professionally. I also want to mention that it is essential in any conservation contest to go through a reasonable and considerate decision-making process, pondering benefits and possible unwanted risks, as we tried to do it for this case. Our activity is critical to better understanding the cultural heritage that reaches the present generations, and we are always successfully realizing that. So, colleagues, let's keep working. Here are the references that I used. And finally, I want to thank you all for listening to me. And I want to give a special thank you to Professor Ana Bidaja, who is always giving me support when I need, and is always willingness to help. Also, I want to wish the best luck to my student fellows, and I want to say I want to give a huge thank you to the organizers of this great event. Please, if you have any questions, let me know, and I hope I see you all until in the next year's ConNext sessions. Thank you.
Thank you so much for your contribution, Mafalda, for your work, the description of the decision process. And now let's continue straight away. Our next presenter is Luisa de Souza. Maybe I'll let our colleagues time to, yes, I'll let our colleagues time to, yes, to share the PowerPoint with us. Luisa is studying conservation and restoration of painted wooden objects and paintings in her first master's semester at the University of Applied Sciences and Arts at Hildesheim. After obtaining her entrance qualification for higher education, she decided to work as a restorer, and she gained practical experience in the field of paintings and painting wood, as well as architectural surfaces. She worked also in museum and took part in a major restoration of a church. In her bachelor's thesis, she dealt with gilding and Swiss gold, which is the topic of tonight's presentation. Luisa, please go ahead.
Yes, thank you for introducing me. In my bachelor thesis last summer, I dealt with the topic Swiss gold characterization and use in medieval wood sculpture in the Lüneburg region. I want to give you a short overview about the content of the presentation. First, I will start with a short introduction. The second topic is about the material technological basics. Then I will tell you something about different analysis, and in the end, I will give you a short conclusion. So Swiss gold, sometimes called part gold in English, is a type of metal leaf that consists of a thin layer of gold and a thicker layer of silver. Swiss gold was commonly used during the Middle Ages, and today the question often arises as to whether it was used for aesthetic reasons or as a cost-saving measure. As in that time period, Swiss gold was less expensive than gold leaf, but more valuable than silver leaf. The use of Swiss gold was regulated in the Lüneburg Guild Regulation of 1497, and it was forbidden to use it without consultation. In addition, there was also a recommendation to varnish it. But how did I came across this topic? I became aware because I found frames of dark polychrome surface on the lower garment of the object I was studying, which could not be classified. The object dates from around 4060 and comes from the Lüneburg area in northern Germany. It is an oak apostle figure that belongs to an ensemble with 5 other sculptures. When I examined it, I noticed that the dark layer glistens a little in some places, and there's a shade of red underneath. My lecturer came up with the idea of doing some research on Swiss gold. It turned out to be a relatively fruitless search. The aim of the thesis was to demonstrate the external characteristics of Swiss gold and to find out if it's possible to visually identify it. Furthermore, the main question about the reason for using Swiss gold shall be clarified. Various analyses were carried out, and I created a sample panel for this purpose. Now we come to the material technological basics. I will briefly explain what Swiss gold is, how it is produced, and what typical appearances it has. As already mentioned, the top layer of Swiss gold consists of a gold leaf and the bottom layer of silver leaf. Because gold and silver have some identical chemical and physical properties, it is easy to let both metals diffuse with pressure alone. The structure of the atomic radii is almost identical. As gold and silver particles mix with each other through diffusion, it is almost impossible to see the layers separately under the microscope. The gold foil is so thin that it cannot prevent the process, and the silver easily oxidizes. Now a brief excursion on how leaf metal is produced. The left image shows a roller from the Gold Beaters Museum in Schwabach in southern Germany. With the roller, the gold can be rolled out quite thinly to then be further processed into gold leaf with various hammers. This method was used to produce gold leaf until the end of the 20th century. Nowadays, leaf metal is produced mechanically, but I couldn't find out exactly how Swiss gold was produced in the past and today. In the following section, I will only show a few important excerpts of different appearances. The most typical appearances is a black, dull surface, as already seen on my study object. Often this phenomenon can be found on objects where no coating is present anymore. This darkening is frequently visible in areas that are not easily visible to the viewer, as you can see in the left picture. In this case, Swiss gold was clearly used as a cost-saving measure because it's hidden behind the arms and there is a clear line to the gold that is more obvious. However, Swiss gold is also often found in the folds of the sculptures. A student from Bern made a sample in her bachelor thesis to clarify the purpose of Swiss gold in the depths of the folds. Due to the thickness of the Swiss gold, leaf metal could be pressed well into the recesses without cracks occurring. It is possible that it was preferred for practical reasons. The advantage is also that it enhances the depth effect. The Swiss gold brings more light into the depths of the folds, and sculptures that were in darker rooms could shine brighter. Unfortunately, these areas often appear black today, which completely changes the appearance of the sculpture. Well-preserved Swiss gold can be seen on the Goldene Tafel. The Goldene Tafel is a part of the high altar retabel from a church in Lüneburg. There were already many speculation and theories about the retabel and about the history, because it exists only a few pieces of the retabel today. The time of the origin could be narrowed down to 4020, 4030 through documents, diverse art historical works, and also dendrochronological investigations. The retabel was extensively examined and results were recorded during a 3-year restoration from 2016 to 2019. Both Swiss gold and gold leaf were proven in the painting and sculptures. In general, all metal leaf were found in 2 different qualities. The Goldene Tafel was made with a great deal of material effort, and this awareness is reflected in the handling of the metals. The use of Swiss gold and gold leaf shows that gold was not necessarily used for more prominent personalities, and Swiss gold not for less prominent areas, but rather aesthetic value was prioritized. In addition, it could be proven that metal leaves were already consciously used in the Middle Ages. This awareness increased over time so that different gold and silver tones were played with. So depending on the thickness of the Swiss gold, it could appear cooler or warmer. This slide shows 2 examples of the Goldene Tafel. On the left, the 2 dragons in the picture are covered with a red lustre, on which a green lustre has been sprinkled, what is also a typical phenomenon. The right image shows a detail of the food washing theme. The jug and bowl are provided with a cool Swiss gold over which a coating is applied. Most coatings on metal leaves are based on oil binders. An analysis revealed that some gold varnish is made of boiled linseed oil and colophony. The mixture is also very resinous. Many of the coatings do not originate from the Middle Ages, so it is not certain whether the representation of each example was the same. The test panel was carried out according to some medieval gilding recipes and is intended to show the color difference between gold and Swiss gold. For this purpose, I used red ball. Red ball was identified among all documented objects with Swiss gold that I have found in the Lüneburg region. On the left side, you can see gold leaf, and on the right side, you can see Swiss gold, which is coated with egg white on top. The differences between leaf gold and Swiss gold can be felt already when taking the leaves out of the little book. Swiss gold is more robust due to its thicker foil. In contrast to gold, the surface is smoother after application, and fewer cracks are formed. In terms of color, Swiss gold is significantly cooler than gold and appears slightly greener or yellower in direct comparison. The color tone of Swiss gold is slightly altered by the coating, but this could be due to the high degree of gloss being slightly lost. On the right side, you can see how the Swiss gold has already changed within a good year. It appears much darker, but as you can see, it is not black, it looks more reddish. In the following, I will briefly explain some examination methods that were possible for me in the context of my bachelor thesis, using mostly the example of the apostle. I used the UV radiation, the stereo microscope, 2 different Keyence microscopes, the X-ray analysis, and the cross-section examination. First of all, I made a UV examination, where it becomes clear that the area in question does not fluoresce. It is well known that metal leaves do not absorb under UV radiation, but as pure material identification, it should not be carried out through this method alone. The stereo microscope allows a first overview of the paint layer. The image shows a small section of the undergarment. In this case, even small particles can be captured through the already oxidized layer, which can be perceived with the naked eye. Sometimes it also allows for a look at the layer below, for example at the red bowl. The two Keyence microscopes can take images down to the nano range. With these microscopes, real-time stacking can be performed and the tiniest particles of the Swiss gold can be found. Here we can see gold and silver particles on both images, which are still partially overlapping, even though the piece appears black. The X-ray fluorescence analysis was carried out using the Thermo Fisher handheld device. We used a larger spot of 8 mm as it allows for a larger area to be measured and provides higher significance when dealing with oxidized Swiss gold. The purpose of this analysis was purely qualitative. Therefore, silver and gold were detected. One disadvantage of oxidized Swiss gold is that it could also be a form of alloyed gold. It is recommended to use comparison examples in this case. The last method is the cross-section examination, which can be anticipated that is not a reliable method and usually followed by an EDX analysis. In the left image, we can see the cross-sectional view of an apostle's flaking. You can see a metal leaf and the layer on top and bottom is oxidized. Here we can clearly see that no separation between gold and silver can be distinguished. In another example of an altar from the Lüneburg region, no leaf metal can be detected in the cross-sectional view under reflected light. Occasionally, small particles reflect under the cross polarizer, but they cannot be confirmed as Swiss gold. An EDX analysis was performed to confirm its presence. However, it is not always possible to detect even minimal particles on oxidized Swiss gold, and therefore an EDX analysis may not be able to be performed. So from my own investigation, it is evident that Swiss gold is not easy to identify accurately. More elaborate and expensive methods are often required for this purpose. Technological examinations such as microscopic examinations, EDX or X-ray fluorescence analysis are unavoidable methods to be able to speak certainly about Swiss gold. The X-ray fluorescence analysis is also a good non-destructive method. The identification of oxidized Swiss gold is particularly difficult, making it more likely that it is not examined or mistakenly identified as oxidized silver. Through extensive restoration work and research on the Goldene Tafel, some insights have been gained into the layering structure of gilding Swiss gold. The thickness of the gold can cause variations in the color tone of the Swiss gold, resulting into two different qualities of gold leaf. Furthermore, research in the Lüneburg region revealed that Swiss gold was used for cost-saving measure, artistic and material technical reasons. It is used in areas such as fold depths and edges, as well in conspicuous places. Meanwhile, there are further studies on Swiss gold from the restorer King Wu from the University of Zurich. She was continued to investigate the metal leaf and has already made some new discoveries. So thank you for your attention. If you have any question, please don't mind to ask. And here are my bibliography. Yes.
Louise, thank you very much for your very, very interesting talk. I'm sure we'll have some questions for you. And we arrived to our first Q&A session, and we're going to start with some questions for Emmanuel Mercier. Emmanuel, could you please join us? Could you please unmute your microphone?
Yes.
Yeah. So we'll start with one question from Leon Petke, and he asks, how did you remove the wax coating from the sculpture without damaging the protein-based layer?
Okay, so on the altarpiece, the wax coating were removed using shell salté mainly. Yes, they were sensible to shell salté. So
Thank you. For a second question from, I'm sorry, Antti Zigalski. Thank you very much for that insight in your work. Maybe I missed it. For the first example of the altarpiece, do you know which wood species were used and why the overall object color changed from the original? Was the artist's intention to a reddish one, a modern taste? So, two questions. The wood species?
yes,
And
so it's all oak. I mean, the altarpiece is made of oak, and all the new parts made by Soest in the 19th century are also made of oak.
Okay. Thank you. And the second part of the question is why the overall object color was changed from the original to a reddish tone? If this reddish tone was a more modern approach, a more modern taste from Soest, probably.
Yes, like colored patina and especially dark patina were quite on fashion in the 19th century. And we find them on many altarpieces. Vincent Cattersale would remember the Saint-Denis altarpiece that was covered also with dark coating. We have just restored another altarpiece that was also covered with first reddish, then dark, very dark coating in the beginning of the 20th century. So yes, it's a question of taste. And for Est, the application of colored patina help also to better integrate the additional part that the change that they made.
Okay, thank you. One question from Pauline Chassang. By saying restoration should not be mixing different periods of time on aesthetic reasons, do you mean the time of the technique and materials only? Or should we consider also stylistic considerations?
I think I mean everything in the sense that we shouldn't, yes, mix different different period of time and have at the end like an historical false. I mean, for example, we shouldn't keep one part of one period, but remove another from the same period. The important is to reach a state that has existed in the lifetime of the object, and that's really the challenge because it's not easy at all. First to be sure, and then also to make the decision, because sometimes we would like to make our own choice, aesthetic choice, but we have to to keep certain
Balance everything.
yes.
Thank you. One final question from Sophie Blarum. Regarding the whitish wax layer that was on the sculpture, could it have been wax bloom from the darker layer underneath?
No, there were really a different layer of wax, and the like whitish one didn't contain any pigment or colorant, only beeswax, whereas the dark wax contained quite a lot of pigment and colorant, Prussian blue, white pigment containing zinc, and also a colorant, artificial colorant. So there were different, in that case, different coatings.
So thank you very much, Emmanuel.
Thank you, Emmanuel, for also answering my
Thank
question.
you.
And we have also some questions for you, Mafalda. If you could please unmute your microphone.
Yes,
The
sure.
first question, thank you. The first question for you is about the layers you removed. Did you document the removed layers? And if so, how did you?
Yes, I removed some layers, and I did recorded everything by photography through successive photographies. During all the process, and is not yet finished, so I continue to do that. Also, I showed to you some photos and with the use of Dynolight digital microscope for each layer, and in each layer in different areas, like for example in the face, lips, investments, eyebrows, head, to everything to be like documented.
Okay. And the second question was also linked to the question of the layers. There was a question about the difference of qualities that you mentioned between the layers. Could you develop the difference of qualities that you observed? Which type or which
Okay.
kind of observation you?
I was able to perceive in the brush strokes and in the thickness of the paint, like in the more recent ones, the paint was more thick, and the carved details got missed because the paint was so thick that the surface was much more uniform. Then in the details of the painting itself, for example, the eyebrows, and in the more recent ones, there was no like the eyebrows, and like in the lips, the recent ones were did more at a rush without so much care, and in the mixing of colors, the oldest one and much more color and expressiveness in the face, like the blush in the cheeks. The recent ones had just a solid color in the whole face, and like difference like that. In the vestments, the stofado is a rich technique. I can send you a link in the chat if you want to explore more about the technique.
Yes. Thank you.
And okay, it involves gilding and then applying a layer of paint on over the gilding.
Thank you so much for your detailed answer.
Thank you. For the final questions in these Q&A sessions are for Louisa. Louisa, can you please unmute your microphone?
Yes.
Hello. From Eleni, she asks, thank you very much for the presentation. Was the egg white coating prepared in a specific manner before the application?
No, it was not. It was just egg white and water, but it's also a recipe from the Middle Age. Yes.
Thank you. And were you able to measure the thickness of the silver leaf?
Sorry, can you repeat it?
Were you able to measure the thickness of the silver leaf? below
No.
the gold?
Sorry, I don't understand the question.
That's okay. I'll try to put it in the chat. I'll just ask you the next question because it's similar to the other one. For instance, the switch gold used on the same ground were used on the same grounds as regular gold leaf, like red gold.
Yes.
And
Yes,
is it used both for water and oil gilding?
Yes, it is.
Okay, thank you. Thank you very much. Pauline?
Yes. Well, thank you, Emmanuel, Mafalda, and Luisa. Thank you also for the interesting questions. I just want to remind you now that the book of abstracts exists, and this PDF can be found on our share box, Dropbox folder, and contain abstracts of all papers and posters of this edition of ConNext. You can find the link to the folder in the chat, and in this folder you can also find the posters of ConNext. Now we are going to take a little break of 10 minutes. So get yourself a cup of something nice and see you in 10 minutes. Bye.
All right, welcome back, everyone. I hope you all had a refreshing break. Before we proceed with the following presentations of this evening, day, or afternoon, I would like to make a quick announcement that all sessions of ConNext of the last 2 years are now freely available on YouTube. As you can see, there's a QR code available on the slide, but I will also provide you with a link to the YouTube channel itself. There you can all view the previous sessions, and you can just click on any video, and all presentations of last 2 years presentators are marked with a timestamp, so you can freely browse as much as you like. And I will give the floor again to Anna.
Thank you. Oh, sorry. I'm always missing my script. Thank you very much. No, sorry. Sorry. Our next presenter is Aspasia Kopsida from the Department of Conservation and Restoration of Cultural Heritage of the University of Amsterdam. Aspasia is a postmaster student in wood and furniture. She received a bachelor in conservation of works of art at the Department of Conservation of Antiquities and Works of Art of the University of West Attica in Athens, as MSc in Conservation and Restoration of Cultural Heritage, with a specialization in wood and furniture at the University of Amsterdam last year. In 2020, she worked in Maastricht as a conservation fellow on polychrome sculptures and frames. Her research interests are in the area of conservation of furniture, painted and decorative wood, panel paintings, frames, and historic construction techniques on woods. She will now present a preliminary study on the use of multispectral camera Crimlit Auto for the detection of synthetic dyes on wooden substrates. Aspasia, please.
Thank you, Anna, for the introduction. Good evening, everyone. So my presentation tonight will be about the results of a preliminary study on the use of the multispectral camera Crimlit Auto for the detection of synthetic dyes on wooden substrates, which took place during my 3 months master thesis last year. This presentation will start with the case study object that led to this research and the fading phenomenon that occurs the light-sensitive dyes. A few technical aspects of the camera will be mentioned, following by the experimental reconstructions that took place during this research, the results, and a few remarks at the end. To begin with, for the current research, a 20th century marquetry table from 1939, designed by the Dutch artist Nel Classen, was used as a point of departure into looking for original colorants with the use of the camera. The table was part of the interior of the Dutch ship MS Oanyi. The table is displaying the mythological figure of Persephone. Marquetry is used for the decoration of the tabletop, and more specifically, 7 different wood species were used as referred in the technical drawing, namely pear, ebony, figured birch, tulip wood, olive burl, satinwood, and maple. In their current state, the colors of the veneers have become faded to various shades of brown compared to the design drawing, which may provide a more colorful image based on the color key index. It remains unclear if the color key index was referring only to the suggested wood species or also to the colors that the veneer should be dyed, as the majority of the color choices follow a natural approach, such as the skin tone and the clothing. But is it possible the dyes to fade to such an extent that cannot be detected via visual examination? Among other types of dyes, early synthetic dyes were in popular use during the late 19th and early 20th century and are known for their poor light fastness properties, so much so that in some cases only the natural color of wood remains now visible. In this slide, we can see the severe fading of 3 of them after 80 years of artificial aging. With the aid of the multispectral camera, based on the visual indication of the drawing and the object itself, a few areas of the marquetry composition were examined and photographed. The figured birds of Persephone presented a bluish fluorescence, in some cases more intense than others, such as Persephone's legs and ribbon. It was interesting to note that the fluorescence followed the texture of the curly figure. Additionally, under ultraviolet light, the tulip would appear to have a rather dark orange fluorescence visible on Persephone's hair. At this stage of the research, it was not possible to further interpret the different types of fluorescence observed and determining straightforwardly the presence or the origin of the colorants. Thus, and as long as the crime light auto camera has not used in similar case studies before, a set of 15 early 20th century synthetic light sensitive dyes was chosen to be examined, with the main research question to be: can indication of dye be detected by means of imaging techniques? And is the multispectral camera a suitable tool to detect the presence of early 20th century synthetic dyes on wooden substrates? The starting point for the reconstruction was the known UV fluorescence of the above-mentioned veneers on the marquetry table. The reconstructions underwent accelerated aging and were examined with the same multispectral camera, as well as the same illumination and filter combination as the Persephone table. The reconstructions were executed with the aim of assessing the dyes used on furniture and marquetry by observing their fluorescence at their various light sources. But first, a few words regarding the camera. The Crime Light Auto is a camera commonly used at crime scenes in order to detect, examine, and capture evidence. It's a handheld camera which has 7 types of illumination, emits from 350 nanometers up to 900 nanometers wavelength, and it has 9 imaging filters both on visible and ultraviolet spectrum, providing numerous combinations. For the examination of the dyes reconstructions, 10 illuminations and filter combinations were chosen based on the ones used for the examination of the table and those frequently used in the field, with the main focus being fluorescence under a UV light source with various monochromatic filters. Let's go back to the reconstructions. The colors researched are those present in the technical drawing of Persephone, namely yellow, orange, red, blue, green, and black. In total, 142 dyes were selected and identified by the color index name after an extensive literature research on primary and secondary sources. Following their color index name, a selection of dyes with poor and fair light fastness properties were made with ISO values 1 to 3, based on the hypothesis that light-sensitive dyes could have been used on the marquetry composition. 15 dyes from the RC historical collection were selected for testing, namely Naphthol Yellow S, Chrysodyne, Fast Red, Rose Bengal, Scarlet, Rose Bengal 3B, Floxing, Congo, Methylene Blue, New Blue, Nile Blue, Alkali Blue, Methyl Green, Fast Green, and Nigrosine. It became clear during the research that many parameters could affect the overall color produced during the dyeing process. Fortunately, the major parameters and variables in this process have been already researched extensively by Van Bommel and Fantini, who have developed a standard recipe with 10 parameters, as it can be seen on the table. Pre-wetted thin maple veneer was used, and each piece of veneer was dipped in a water-soluble dye solution for 15 minutes. The dipping method was preferred, as it seems to be more historically and technically accurate. The mock-ups were artificially light aged for 24 days in a self-constructed accelerating aging chamber under daily and UV light in a relatively stable environment with an approximate relative humidity of 50% and temperature of 20 degrees Celsius. After the painstaking dyeing process, the set of the reconstructions of dyes before and after aging. At the bottom right corner, the blank veneer can be seen and be compared with other reconstructions. The amount of data derived from the multispectral imaging was large, so only a few representative pictures and the results of the research will be presented in this presentation. In general, it can be observed that the dyes, even if they have similar light fastness properties, have faded to different extents. I would like to highlight a few observations regarding the blue dyes as well as the red dyes. To begin with, the alkali blue has a distinctive white fluorescence under the UV before fading, which loses after the aging. New blue is one dye captured having a mild orange fluorescence after fading. And these first two examples are referring only to UV light without any filter. Very interesting is the filter combination F4 with light source at 365 nanometers with a filter at 455, which appears to be the most promising and important one. Most of the fluorescences captured have a weaker intensity after the fading. However, many characteristic colors occur before and after the artificial aging. New blue and fast green were captured with a very distinguished blue salmon pink fluorescence. Furthermore, the night blue developed a bright orange fluorescence from the dark red it had before the aging. The rose bengal 3B and the floxine have a rather strong fluorescence under the F4 filter combination before the fading, which unfortunately disappears after the artificial aging. The observations from the F4 combination were also repeated under the F9, which emits at 365 and 445 nanometers with a filter at 495. In this case, though, the alkali blue developed a unique cyan fluorescence before the fading process, which again lost after the fading. A rather interesting and promising comparison is between the methylene blue and the Nile blue. Let me help you reading this slide because it's quite busy. So methylene blue and Nile blue, and here we have 5 different filter combinations. Always on the right side, we see the methylene blue, and on the left, and then on the right, the Nile blue. They have similar light fast properties. However, they present similar extent of discoloration with similar deviation of their hue. Their appearance, though, changes drastically under the various filters and light sources, as can be observed on the slide. Methylene blue burns any fluorescence, whereas the 9-blue has a variety of red, orange, and pink fluorescences, creating a characteristic sequence for the current synthetic dyes. Reaching the end of the presentation, it appears that each of the synthetic dyes from the RC collection and the illuminations and filter combinations used has a unique sequence of fluorescence. The amount of dyes that remained on the wooden surface appears to be comparable to the intensity of the fluorescence that was detected with multispectral imaging. Dyes that belong to the same color group, such as the blue, appear to have different hue of their fluorescence, which means that potentially they can be distinguished by means of multispectral imaging, as we saw in the comparison of methylene blue and 9-blue. The case of alkali blue is of significant importance, as it differs drastically from the other dyes, having a white fluorescence under the UV and F4 combination, as well as a unique cyan fluorescence before the artificial aging. The filter combinations F4 and F9 are promising, as they give a wide range of fluorescences, while the F3, F7, and F8 provide with a rather limited amount of information. Based on the possibilities that became apparent, and despite the limited number of dyes examined, it can be concluded that there's strong evidence to suggest that the use of the crime light auto could be used to differentiate between dyes with similar appearance under normal light, but a unique sequence of fluorescence under the various filters. Nevertheless, for an observation of this kind to be conclusive, it has to be examined through a broader range of dyes, not only on the ISO value, but also the dye class, so that the observation can be reevaluated anew. Here we have a few of the references. Maybe I'm passing the time, so I would like to thank briefly first of all, my supervisor and teacher, Sophie Clerum, people from RCE, Shepherd Museum for providing the objects, and then my friends and colleagues, Katerina, Anthea, Valentina, and Andreas. And of course, thank you for your attention.
Thank you so much, Aspasia, for the sharing of your very innovating study. Next up is Pauline Natosh from the University of Applied Sciences and Arts at Hildesheim. I'll let our colleague the time to open the PPT. Thank you. So Pauline is studying in the first master's semester in the Department of Furniture, Wooden Objects and Material Combination. Before that, she completed a carpentry apprenticeship, and during her preliminary internship and practical semester at Hildesheim, she worked in independent restoration workshops in Germany, assisting, for example, in the reduction of mold contamination in a church and other monument conservation activities. She worked on her bachelor thesis in cooperation with museums in Lower Saxony. In the furniture depots of these museums, she documented surface phenomena in transparent furniture coatings. In her master's thesis, she plans to deal with transparent coatings or monument conservation issues, especially with wooden objects bound to buildings. So now, please, Pauline, go ahead. You're welcome.
Thank you very much for the introduction. I would like to welcome you to my short poster presentation about my bachelor thesis with the topic Surface Phenomena of Transparent Coatings on Wood. Transparent or unpigmented coatings increase the sheen and deepen the color of the wood, and therefore they influence the overall visual appearance of a wooden object. and they protect the wood from dirt, grime, and mechanical impact and reduce the influence of atmospheric pollution and moisture. Due to various factors, these main functions can be severely affected by damage and irregularities in the coating. They can be detected by optical phenomena on the surface. For accurate documentation, it is important that all people who work with wooden objects with transparent coatings are able to recognize these phenomena and name them precisely. For this purpose, I started to collect surface phenomena, mostly on furniture, photographed and described them, and try to give a suggestion for naming according to optical characteristics. The phenomena found can be divided into the following groups: cracks, detachment from the substrate, color changes, and structural irregularities inside the coating system. Understanding the causes of surface phenomena of transparent coatings on wood is important when discussing the choice of appropriate conservation treatments. For this purpose, I have considered possible causes due to climatic, anthropogenic, biogenic, and technical influences and assigned them to the phenomena. Due to the short time available, I will only give an overview of the causes today. The exposure to moisture, UV radiation, and extreme temperatures during and after curing of the coating can cause, for example, color changes and shrinkage, which can lead to tension and detachment. The substrate material wood can cause an uneven surface or detachment due to its species-dependent ingredients, its porosity, or incorrect treatment before the coating application. Historically, coatings were based on natural resins in various formulations. Later, they were replaced by synthetic materials. Both the historical and contemporary ingredients affect the liquid film, and thus the application method, the curing process, and the aging behavior. This can result, for example, in microholes, wrinkling, and cracks in the coating. An important factor is the former treatment of transparent coatings. The application of new coatings over historic ones can lead to dissolving, detachment, or diffusion of the different layers, making later separation difficult. The removal of historical coatings, especially with alkaline materials, can cause, for example, graying, staining, and shrinkage cracking. I would also like to mention damage caused by packaging materials, especially adhesive tape, because these have occurred relatively often in my collection phenomena as missing parts, residues on the surface, and color changes. The influence of microorganisms occurs mainly after damage to the coating in the wood, but especially the treatment with biocides is important to recognize for health reasons. This is indicated by crystalline efflorescence on the surface. In conclusion, I can say it was a very extensive topic, and that this thesis is an introduction for deeper considerations of surface phenomena, their causes, and appropriate treatment. And my collection can still be extended and intensified. Due to the countless historical and contemporary materials of the coating, the hygroscopic characteristics of the substrate material wood, and the interactions between these components, the close examination of transparent coatings on wood remains an important topic in restoration practice today. With that, I like to refer to my poster, which I will upload, and thank you for your attention, and I look forward to answering all the questions you may have.
So thank you, Pauline, for your very interesting talk. And last but not least, Abby Tudor will talk about the Anglo-Indian Sabelli Workbox Conservation Project. Abby began her career as a designer, making high-end acrylic furniture in New York. After graduating from Loughborough Design School, she moved to India, where she ran production and global sourcing for Swoon, a London furniture brand. In 2021, after taking a short course in fine furniture making at Rodin Atelier and working as a furniture restorer, she began conservation studies at West Dean, where she specialized in furniture and related objects conservation. She completed the graduate diploma in 2022 and is now studying the MA. She has a particular work placement. Sorry, my internet just went out. And just complete the work placement with Heritage Malta, where she participated in the conservation work on ongoing cultural heritage objects. Please, Abby.
Hi, good evening.
Abby?
Thank you very much for the introduction. Can you? Hello?
Yeah, now we can.
Okay, great. Hi, everyone. Thank you for the introduction. Thank you for the opportunity to present today. I'll be talking about the treatment of a Sideli workbox from the early 19th century. Just seeing how to share the... Okay, so I'll take you through the history of Sideli, how you can date the items and how they are made. I'll then discuss the client's box, its losses, and the treatment options that include the material analysis that I carried out, the verdigris testing that I did, and bring you to where I am today with the reconstruction of the Sideli. I'll also summarize with some potential further developments. Sideli is the Hindi name of the type of marquetry that is primarily associated with the town of Surat on the coast of Gujarat. The technique originally came from Persia, where it is called katam, and was probably first introduced into Surat in the 17th century. Indian craftsmen developed their own distinct forms from there. By 1903, the chief centres of its production also included Ahmedabad, Baroda, and Bombay. You may have heard the term that these referred to as Bombay boxes. They were predominantly export items for Europe and included equipment such as sewing kits and that were known as workboxes. In terms of conserving this type of object, only one published report was able to be found where photographic reproduction was used. I'll give a brief example of how this worked, along with other treatment options I explored, and explain my reasoning for choosing a different treatment plan. I'd like you to take away from this talk an understanding of those techniques and processes involved in the treatment of this box. When assessing a Sideli workbox, it can be roughly dated by both the design of the Sideli, the materials used, and the shape of the box. In the late 18th century and early 19th century, boxes were typically simple in design, but completely covered by the intricate Sideli marquetry. Earlier examples do not have metal in the design, as this was introduced around the turn of the century. But from the 1820s, the shape of the boxes started to become more decorative and sit on silver or ivory feet, while the amount of Sideli was slowly reduced using larger sections of wood or ivory veneer. This was to save on the cost of the materials and labour required to produce it, and by the late 19th century, these veneers were larger still. Sideli is created by cutting, filing, and gluing long strips of different materials and shapes into packs. They are usually equilateral isosceles triangles that make up repeat patterns, often centered around a six-pointed star, as you can see here. The packs are then cut into slices that form veneers, each one showing the pack's cross-section. Materials used are often horn, bone, ivory, ebony, and various metals. The object being treated is an early 19th century example, which you can tell from the design of the box, the complete covering of Sideli marquetry. It includes both sewing equipment and a writing slope and a drawer. It has a number of losses, with the largest areas being on the back of the lid and the top of the lid. You'll notice also the lid is unattached from the base, and there are various other repairs that were required, which I won't go into in this talk. This report was from the Canadian Institute of Conservation, and it found that it was found on a similar box with similar issues. They used photographic reproduction to fill the losses, where a photograph is taken of the complete area of Sodeli, printed on high-quality paper and placed onto a wooden veneer, and then filled as a patch. I also experimented with the idea of epoxy resin veneers, casting them from the surface of the marquetry box to get the texture, and also looking at gesso fills that could be then painted to match. After discussion with the client and for my own personal practical development of skills, it was decided that the correct treatment would be to recreate the Sodeli, simulating as close as possible the original techniques and keeping the tradition. So to understand the materials used, scientific analysis was carried out, including magnification of the surface, which showed that the green segments and the white segments were completely different in their cellular structure. So when cross-referencing this with online images, it suggested that the green was actually a type of antler. Secondly, it was important to try to work out the dyeing material used for the green segments. So XRF analysis was carried out, and this showed that traces of copper were present in the green segments only, not in the ivory pieces, which indicated a copper-based dye, possibly a verdigris. So the available literature helped to confirm these materials. A catalogue of the Indian Department, London, for the Vienna Universal Exhibition of 1873, written by J. Forbes Watson, was found online. Within this text, Watson details the materials used to make these boxes, and he describes the ivory as always white and samba horn as always green. So samba is a vulnerable species of deer in India, and their antlers could well have been used as available material at the time. He then goes on to say the colour is produced by steeping it in verdigris, dissolved in lemon juice, toddy, or vinegar. Stalker and Parker also describe staining wood, ivory, horn, and bone with verdigris as well in strong white wine vinegar. So it was decided to imitate the ivory and samba horn pieces with bone as a readily available material today. To achieve the green colour, the original method described by Watson in his catalogue was tested. With this experiment was threefold. One was to check that the bone could be dyed with the verdigris. Second was to check the difference in the colour from the different dyeing techniques to find the right recipe. And third was to ascertain if exposure to light would lead to any change of colour. The purpose was to select the right recipe and produce a colour match to the original box. First, making natural verdigris was tried, but the amount of verdigris required for the experiment was too much, so synthetic dye was ordered in. So the recipes for the verdigris mixes, ideal for dyeing bone, are not easy to come by. Several samples were then needed to find the right one. So a total of 6 in different strength dye baths. Some were mordanted with alum, some fixed with ammonium sulfate, and some simply washed in boiling water. Bone samples were left in for specific times and then all labelled. It was decided to use a UV light chamber to try to simulate the light aging, as literature suggests that verdigris does turn from blue to green over time, which suggests the colour of the box. Once ready, the colour of the original pieces and the new bone samples were recorded using spectrophotography, placed in the UV chamber for 48 hours, and then recorded again to find a close match. Measuring these exact colours was quite problematic, as the size of the samples was so small, only about 1 millimetre of the piece from the original box. So it didn't fill the full window in the spectrophotometer. However, the technique did allow to see some differences between the dyed samples. It was found that there was a slight colour change in the samples after exposure to UV light, particularly in the ones that weren't fixed with ammonium sulfate. So they changed from a bright blue to a sort of greener hue, which is beneficial in attempting to match the box. The best match was found to be sample number 5. As you can see here, it's a 5% solution of verdigris left for 7 days in the dye bath, boiled in water to wash it, and once dried, it was put in the light chamber for 48 hours. Once this was confirmed, then full strips were then placed in the dye bath, and the same technique was followed. So meanwhile, to practice the actual creation of the Sodeli, a practice pack was created using the available strips of wood that were kindly supplied by a previous student who had studied the Qatar marquetry from Iran. This was to familiarize myself with the process and plan how the pack should be built up, in what order, and using the right techniques. So for the final pack of Sideli, bone, ebony, tin soldering wire, and rosewood strips were prepared in the required shapes. The material was processed using a bandsaw with an angled bed to cut triangular strips. Following this, they were all placed in adjustable jigs that were specifically made for the sizes required, and the strips were filed down to size. The tin was drawn through an extrusion plate and then rolled to create the central circle and surrounding triangles. So a small test of these materials was built up to check that the sizing, and again, that my technique was correct in building the pack to the right pattern. So a few problems were encountered from this test. So you may be able to see here that the green sections of my pack are actually a bit small. They weren't quite large enough to fill the full shape required. And secondly, that despite having gone through the same technique as I had experimented with the dyeing of the verdigris and the light aging, it was still quite blue. So I sliced a piece off and placed it back in the light chamber for a further 48 hours, which again reduced the blue to an even greener color, closer to the match on the original sample, as you can see on the right here. So for further development, could be carried design of the jigs to make the size and shape more consistent and easier to reproduce, thus making Sideli repairs more accessible, especially this type of repair, and more time efficient. An example here is taken from a book on bamboo fly rods, which are also made of equilateral triangles and also bound in a very similar way. And this jig could be adapted to suit the requirements of Sideli to allow strips to be processed through a router instead of a hand filed down as the traditional technique suggested. So work is still required to create new sections of the green bone, which is currently underway in the workshop. And I'll be getting straight back to that. This treatment process has exceptional craftsmanship skill required in creating Sideli workboxes. While the treatment in this box will be distinguishable from the original by way of the materials used, I do believe that it will keep the integrity of the object by replicating the original techniques as closely as possible, which is as the client desired. So finally, I'd like to thank all my tutors for their ongoing support in this project, thank the college, Western College, and of course the clients, without whose kind permission I wouldn't have been able to carry out this work on the piece. And I'd like to thank you all for listening, and the organisers of ConNext for putting this together for us. Thank you.
So thank you very much, Abby. Wonderful presentation. And we now have our last Q&A session for this evening. And again, there are quite a few questions in the chat box, so we are going to select some. And questions in the chat box, so we are going to select some. And I will start with Aspasia. From Abby. Aspasia, are you?
Yes.
Aspasia?
Yeah.
Hello. One question from Abby Tudor. How did you calculate the relation between the time spent in UV light chamber with the equivalent number of years of aging?
So my goal wasn't necessarily to calculate the years, but more try to fade the reconstructions as much as possible, so to imitate the marquetry. But roughly, I can tell you there's a coefficient I could use based on the light source, temperature, and relative humidity. And these 25 days of artificial aging was equivalent to almost 30 years of aging.
Thank you. Another question from Welmut Kreb. Sorry, I might have missed, but how many combinations of light and filters did you test? There's a second part. And also, did you also test them on your object? For instance, on the blue, So it's three questions. And how did you make the artificial aging chamber? So first, how many combinations of light and filters did you test?
I test more than 10, but I think the most important was the 10 I presented. So mainly visible and UV light with multiple monochromatic filters.
And the second is, did you also test them on your object, for instance, on the blue?
Yes, that was actually the starting point of this research. There was this marquetry. I wanted to understand if it was dyed or not, because I couldn't see with a visual examination any remains of dyes. However, I had this technical drawing, probably meaning that they have been used dyes, the construction. So I had this unknown fluorescence. I wanted to understand what exactly it means and if that refers to use of synthetic dyes.
And the final part is, how did you make the artificial aging chamber?
You mean how I constructed it? I didn't. I found it at the basement of RCE. But it was basically a box with light tubes and ventilation to keep the temperature and relative humidity quite stable.
Thank you. One last question from Emmanuel Mercier. Very interesting. Did you cross your observations with real object like the table?
I guess you're asking the observations from the reconstructions. And unfortunately, I didn't because I didn't have access to the tables anymore. But I could say that the intensity of the fluorescence was quite different. The reconstructions was we can't really tell, I guess, from a picture. But from the reconstructions, most of the fluorescences were quite intense. Compare this to the table, and also different colors and different hues.
Okay, thank you very much, Spasia. So we have some more questions, but for time management, we'll send them for you by email. Okay?
Yes. Thank you.
Thank you.
Thank you, because we have also some questions for Pauline and Abby. Pauline, can you please turn on your microphones, please?
Yes.
Yes. So first question, do you think your approach could be useful to other specialty in conservation?
Yes, I think especially for varnished paintings on wood, because varnishes are, the materials used for varnishes are quite similar to the materials used for transparent coatings, and I think it's likely that similar phenomena can occur on the surface. Yes.
Thank you. Another question is about the process. Did you establish a standardized process of taking photographs in order to be able to compare the results of collecting damages?
No, I didn't. That's something that could be improved.
When you go further in this research,
yeah,
okay?
Right.
And the last question, were you able to link certain typical surface phenomena to types of finish?
Yes, I have. Yeah, you can read it in my thesis. Yes, I don't know right now.
Yeah, so we will
So,
see in the publication.
yes.
Thank you.
So our final questions are for Abby. Abby, please.
Yes.
From Belmont. Did you consider using a substitute material for the ivory, as the surface is so small?
Yes, so for the ivory, I'm also using bone, but just in its natural, well, as it's being bleached. So the bone will be used for both the ivory and for the green samba horn section.
Bone from which bone? From which?
It's camel bone.
Okay. Another question: if you would have to do it again, would you again use verdigris?
That is a good question. I am not very knowledgeable in the extensive different types of dyes that you could use. From what I do understand about verdigris, though, there are different ways of making it, and I was interested in looking at changing the way a natural verdigris could be produced that might give a slightly less blue corrosion product than the synthetic verdigris that we ordered from Kramer. But that would be another bit of research into the corrosion of copper as well. So I think in terms of keeping it traditional, verdigris is throughout the literature for the natural dyeing of these objects. So I'd like to have kept it within that range. Yeah.
Thank you very much. Wonderful presentation. Wonderful.
Thank you.
Thank you, Abby. This Q&A session brings us to the end of the third ConNext session 2023. I would like to thank our keynote speaker, Emmanuel Mercier, and a big thanks for you all speakers of today, Mafalda Afonso, Luisa de Souza, Aspasia Kopsida, Pauline Natouche, and Abby Tudor. Finally, I like to thank our institutes and partner ConNext, and last but not least, you, the audience, for making this event happen. We hope you had a good time during this last session for 2023. And before we finished, Sophia Nasser, maybe you would like to say some final words?
Yes, thank you, Pauline. Hope to see you next year, and until then, you can watch the videos from this and previous sessions on YouTube. So to soften the way till next year. Okay, hope to see you then.
Thank you, Sophie. Bye, and see you next year.